Okay, so now we're at worksheets 31 through 34, and I'm thinking of that all as a unit together. This is just more examples, and so primarily what I'm going to give you is hints. There are a couple little topics, but you've hit all the big ones now, and for the most part, between worksheet 31 and 34, you can just flip to any of them and just start working the problems if you want. Okay. The one thing I want you to learn that's slightly new but not totally new on this worksheet is this idea of average value. Okay, so if you have a function over an interval a to b, and you want to know what the average value is over this interval, what you can do is you can just integrate this guy, f of x dx, integrate it from a to b, and divide by the length, which is b minus a, the length of the interval. And so what you want to visualize is that's going to give you some sort of value where all the negatives and all the positives average out. So maybe I drew that too high, maybe something like that. So in your mind's eye, you want to find a red line such that this positive area here above the red line has to equal to this area down here below the red line and above the curve. So that positive and negative has to balance out. So that's the visual on that. And you can think of a car traveling at an average of 65 miles an hour, but it goes a little faster and a little slower, something like that. That's what you should be thinking of. So this is going to be your average value. Okay, so with that little definition out of the way, I'm going to just start making up questions that are similar to your worksheet so that you have something to look at. But for this and all the following videos, you're more than welcome to start working on the worksheets first and then come back and watch the videos if you need help. Because again, there's nothing particularly new on these worksheets, it's all just hints. Okay, now suppose that A is less than B, and they're both positive, and you're integrating from a to b, and let's say you're integrating x cubed plus x dx. Can you create an expression that does that for you for any a and b? All right, so a couple of things I guess to just make sure you know about integrals. If you have f of x dx equals capital F and g of x dx equals capital G of x, these are additive, and you can multiply a constant in front of them too. So it means, for example, if you have 2 times f of x plus 4 times g of x, you want to integrate this thing just like you did with differentiation. So this is going to be 2 integral f of x dx plus 4 integral g of x dx. So that's all legal. And that's a hint that you're going to use later in the homework, actually. All right, so we're going to use it now, and we're going to take the integral of x cubed, and we know it's got to be x to the 4th, but you have to scratch your head a little bit and say, well, if we took the derivative of x to the 4th, we'd get 4x cubed. So we need 1/4 over here to balance that out. And if we ended up with an x, it must be some kind of x squared, but we need a 1/2 in here, otherwise we'd end up with a 2x. And the way we often write this is we put a line here to indicate that we haven't plugged in the endpoints yet, and we just say, to be most explicit, you can say x equals b and x equals a, but most of the time we don't need to be that explicit because we know what our independent variable is, and we just do something like that. Okay, so those are different notational conveniences. You can also get rid of these brackets because usually it's clear what's going on. Okay, now what you want to do is, knowing that capital F of x is 1/4 x to the 4th plus 1/2 x squared, we want to write capital F of b minus capital F of a. Okay, so We usually don't write the letter F at all, but that should be in the back of your mind. So you don't have to write it, but just know that it's always there for you. So what can often happen at this stage is, especially if there's a minus sign somewhere inside a capital F, you can get confused. So if it helps you, put parentheses down as placeholders and then put F of B down and then F of A. So you want 1/4 times B to the 4th plus 1/2 B squared minus 1/4 A to the 4th plus 1/2 A squared. Okay, so that's it. That's looks really fancy, and it's not really fancy. It actually doesn't say anything that profound. But there you go. Okay, well, what if we actually have an A and a B? Then what happens? Try not to erase the integral. Okay. What if this is like a 7 and this is a 3? Well, in that case, the 7 goes here, the 3 goes here, the 7 goes here, 7 goes here, 3 goes here, the 3 goes here, and then you calculate it and you get some number when you're done. Okay, I'm not going to calculate it, but that's the process. I want to remind you again that if you have A to B, f of x is equal to some value, say P. If you switch the limits of integration, A and B, so I've just switched them, then your integral will be exactly the same but negative of whatever value it was. So if it was negative first, it would be positive. If it were positive, it became negative. But make sure you're aware that when you switch limits of integration that you get a negative sign. Okay, here's a couple more hints. There's a question on the worksheet that has some number, let's say L for the low end, and then there's an integral here, and then let's say that's the high end. They say prove that that integral lies between those two values. And this particular exercise goes as follows. Here's what's going on with that one. There's some function, it's either strictly increasing or strictly decreasing, you figure out which, okay, but it's not hitting a max internal or a min internal to the interval. It's not doing something like that, okay? It's not turning around at all inside the interval. So you have to demonstrate that that's the case. And then the two endpoints give you the high and the low point of the function over that interval. And so then you can simply do a lower rectangle and a higher rectangle as your min estimate of the area and the max estimate of your area. So that should be pretty straightforward. So you just have to work out all the loose ends on that and make that work for you. But that's the strategy for that question. Okay, and then the last question has to do with the function sine of x over the interval 0 to pi. And I don't want to give away too much, but I also don't want you to struggle too much with this. I want to give you a hint. So I'm going to just draw a picture hint, and you can take it for what it's worth. And there's probably lots of ways of proving this, but this is what I did. And so if this picture helps you, use it. And if it doesn't help you, then you can prove the statement some other way. Okay? So that's just a hint for you. And hopefully that helps some of you. And that's enough hints. Then you can go work on the worksheet. See you in class.